You know, in additive manufacturing, there are a lot of ways to make metal parts, but there's some constraints to additive manufacturing of metal parts, and one is part size, part complexity. Of course, for very, very fine lattice work, very, very small precision parts, it's a very popular technology, but what if your needs are parts that are somewhat larger? I'm with Tobias Röhrig. She's CEO and co-founder of Gefertec. Tobias, I understand that here at Gefertec, you have a technology which allows you to make parts that are significantly larger at significantly lower cost.
Yes, that's right. We are using standard welding technology with a wire fed to produce very big parts. It's possible to have parts up to 3 cubic meters in size. Because of the technology, we have very high deposition rates, which allows us to have this big parts very fast at very low cost.
Now, 3 cubic meters is a very big build envelope. So clearly this is not a powder technology. What is the technology?
Right, technology is as I mentioned, it's standard arc welding technology, as you know it maybe from joining, from welding. And we use wires as feedstock because compared to powder materials, wires are less cheaper than powders, and also the handling, health issues are better compared to powder.
So this is a MIG process, as we would know it?
Yeah. It's MIG-MUG depending on the material.
Yes. And so it's the raw materials then, these would be standard welding wires that are available commercially?
Yeah, you will get it everywhere. Just check the internet and you will have the wires within at least 2 days.
So the process is to lay a bead and lay a bead on top of a bead to create the pattern?
Right, yeah, that's it.
And in doing it this way, is it possible to create hollow sections in the inside, the way we're familiar with additive processes?
Yeah, it's possible to have like cooling channels or hollow structures. Maybe they look a little bit different than you are used to from powder bed technologies, but still they have their functionality.
Is it possible to make things like molds, for example? You mentioned cooling channels.
Yes.
Conformal cooling, of course, is the great achievement of additive. For molds are a possibility with this tech?
Yeah, actually we're working quite a lot with tool manufacturers like molds, dies, cutting tools, and for the real big parts. They are very precise cooling channels are not that necessary, and because of that, our technology fits the needs of our customers in this industries.
Now, most 3D printed additive parts still require some finished machining at the end of the process, but it's significantly less than machining, of course, from a block of steel before. What kind of savings are possible using this technology?
We have calculated parts that you can produce cheaper for 60–70% depending on the material. If you're working with titanium, for example, a very expensive material, a material which is really hard to machine, and then you can have cost savings up to 70%. When we are speaking about steels, for example, we have a showcase where customers has overall cost savings in manufacturing of a part of more than 50%.
So it sounds like the more expensive the material, the better the savings.
Yeah, that's it. The more expensive and the harder to machine. That's the materials we are looking for.
So it's are there any limits to the kind of material you can build? You mentioned titanium, aluminum, aerospace alloys, tool steels. All are possible? Yeah,
everything that's weldable and everything that you can get in wire. Copper-based alloys, nickel-based alloys, a broad variety of steels, aluminum alloys. Yeah, everything that's weldable.
Is it necessary for a user of your machinery to be an expert in welding?
No, we need operators or we need people that can operate CNC machines, because that's the idea. Next to our 3D printer, there's a CNC machine to do the finishing, and the operator can easily change between these two technologies.
Broad spectrum applications, very, very large parts, says Tobias Röhrig of Gefertec.